Geometry, angle bisectors of triangles, part B of the lesson. So construction is done in classrooms. But I do want to point out that if a circle is inscribed in a polygon, we say that each side of the polygon is tangent to the circle. So that's a very specific way of describing a how a circle could be described as being inscribed, because this literally means is drawn inside or written inside. And then, if you do that, it leaves the possibility of circle being drawn this way, right? We don't want that. So inscribe has a very specific meaning. It's you could draw the circle as big as possible, touching all sides, right? And yeah, so that's why this circle is called inscribed circle, right? What if it's touching all the points here? The circle is circumscribing, right? So there's that difference. So the point that we're going to make here, guys, what's really important about the angle bisector is that the point of concurrency of the angle bisector is called the incenter. And we'll talk about why in a second, right? So the reason for that is here. We know that by definition, right? By definition of the angle bisector, right? The any point on the angle bisector is equidistant from either side. So when you have a concurrent point like this, and like this, so this point is equidistant to this side, and because this point is also on this angle bisector, right? So it is also equidistant to side AC and BC. And this P is also on the angle bisector for angle ABC. So it is equidistant to side AB at point Y and to side BC at point Z, right? That's why this is called a concurrent point, in that three different angle bisector meet at a single point or intersect at a single point, right? So we know that for that reason, PX, PY, PZ are equal to each other, right? And then if that's the case, we could draw a circle around it, okay? That's why it is an incenter. This is called incenter theorem. And if we were to have to go back to why perpendicular bisector is a circumcenter, is that when you have a segment like this, guys, and you got a perpendicular bisector, let's move that a little bit to the right. There you go. Like this, and you could see, and that's point M, and this is perpendicular, right? You could clearly see that these two has to be the same, because, let me just highlight that a little bit here, because these two are the same. It's the same by reflexive property, and then they're both the right angles. So side angle side triangle, right? So this side and this side is so this triangle and this triangle is the same by side angle side. Therefore, by CPCTC, this is the same. So when you have all three of them meet together, so for example, when you have something like this, right? Perpendicular bisector, any point over here is equal distance to this corner. And you have another one over here, guys, this point right there. You only need actually two. So what that means is that this length and this length is the same. And this length and this length is the same. So through that, you could draw a circle. It is for that reason we have the concurrent point of the perpendicular bisector of the triangle is a circumcenter, because it is a center to a circle that circumscribes the triangle. All right, guys. I thought it would be a good point of comparison before we move on. Let me go to the blank page over here. So now the example we have is for us to do this exercise, okay? So we know that JV and KV are angle bisectors of triangle JKL, which means what? That wants to find the distance of V to the KL. So it's here, right? So that's what they're looking for. But we know that according to the angle bisector theorem, any point on the angle bisector here, guys, is equidistant to either side. So if the VW is 7.3, and this point here must be what? Exactly the same. So this has to be equal to VW, which is equal to 7.3. Therefore, the distance from V to the side KL is 7.3. And the measure of VKL, V, okay, okay, there you go. What is the VKL? Interesting. So VKL over here is what? One half of this value here, right? So if this is whole thing is X, let's call that X over 2. Let's call this X over 2. And then this angle here is 106. And this is what? 19. That's right. So this angle plus the whole thing has to add up to 180, right? So that's how you do that, guys. So when I wrote it out, it looks like this, okay? Because these angles have 180. So we were given that this is 106, and we were given this half angle, which is 19. So I have to double that plus the JKL, which is this. And that JKL turns out to be 36, but the angle that we're looking for is half of that amount, right? So one half of that is 18. So this here is part 1, and this is the part 2. That's the order in which you have to solve this problem, guys. All right? Okay. So let's look at this example. This is from your textbook, Module 2. So Module 8, Lesson 2, question number 16. Complete the proof of the angle bisector theorem. That is, but you know, to visualize this, I think we should draw a picture, don't you think? So given information is that the ray PS bisects angle QPR. So P is over here, Q is over here, and R is something over here, and S, maybe over here. So it bisects. So these two angles are exactly the same. And it's saying that SQ, okay, you know what? Judging from the picture, I need to draw this a little bit. Hold on. SPQ and SQ perpendicular. So it's like this. So that is point S. And it is also saying that the SR is perpendicular to PR. SR, so it must be point R must be here. Okay. Okay. So that is a 90 degrees right there. Okay. All right, so we drew a picture. So we need to show now that the SQ, the question mark is, are these points the same? Okay, that's the question. The first one, that statement looks like a copy of this, and that's given to us. So we write down the word given. And then it says that QPS, angle QPS and RPS are congruent. Wait, hold on, what is that? QPS looks like this. RPS looks like that. Okay, they're the same. That is because of this, right? So that will be the definition of angle bisector, right? Because angle bisector divides an angle into two congruent angles, right? And then we have this SPQ and SRP are right angles, but we know they're perpendicular. It must be a definition of perpendicular. Yep, it is. And then we say that these are congruent to each other because if they're both right angles, all right angles are congruent because all right angles are 90 degrees and they have the same measurement. Okay, it says reflexive. So apparently, in order for us to prove that this is congruent, we need to show that these two triangles are congruent, right? Only thing that's overlapping is PS, so that must be the reflexive, right? Right. So PS is congruent to segment PS is congruent to segment PS. So we got angle side. Okay, so the triangles are congruent. So let's go with triangle PSQ is congruent to triangle PSR, right? And we know that the SQ is congruent to SR. That is a CPCTC to say that corresponding part of the congruent triangles are congruent, right? And the rest is just that if you have a congruent segments, they have equal measure, and congruent segments have the same length, or you could simply say definition of congruence. Okay, guys? All right. And that is it for the second part. All right. All right, guys. I'll see you in the next video.